score. What do you mean, why can't I score?
Bruh.
You couldn't score too. I think we should use Dr. Chan's dynamic methods, the trajectory of the ball and the force used. How do we do this?
Right, so first we are going over some of the equations that we need to know before we calculate everything regarding to the real world problems that we choose. Whenever object moves at constant speed, the displacement is equal to the velocity times time. And the other three equations that we have here is actually equations that we can acquire from the linear motion formula, and I believe everyone have known it already. Right, so for the real life example that we choose is basketball. On how do we shoot the basketball ball every time so that the basketball ball will land inside the hoop every time. So first we drew the trajectory of the ball on a Cartesian plane. This is what we did. And there are several things that we have to make it constant, and that is the height of the ball release, which is the height of Nash, 1.7 meter, the height of the hoop, the string to throw the ball, and the angle of the ball when released. So we have already did the calculations, and the first thing that we did is that we drew the ball trajectory on Cartesian planes. Knowing that the speed of the ball is 7 meters per second, so in these calculations, what we want to find is the distance that Nash should take to score, to shoot the ball. And first we did the horizontal component. So the horizontal component that we did, the displacement, the final displacement is equal to the initial displacement plus velocity plus initial velocity times time, and they supposedly have plus 1 over 2 times 8 times time to the power of 2, but then the accelerations of the horizontal component is 0, so the formula remain just like this, and then we input the value of the initial displacement and the initial velocity of the horizontal component, and so we get an equation which is the final displacement of horizontal component is equal to 7 cos 60 degree times t. That is the first equations. And continue with the vertical component. The final displacement is equal to the initial displacement plus initial velocity times t plus half of accelerations times time to the power of 2. And then just like what we did with the horizontal component just now, we input the value that we have already obtained, and then we calculate the value, and then what we get is that for t we get 0.9598 seconds and 0.2761 seconds, and we use 0.9598 seconds because 0.27 seconds is too fast for the ball to travel, and so the value that we use is 0.9, and then we input 0.9 in equations 1 that we obtained just now, and then the final value that we get is 3.36. So we have already obtained our horizontal displacement of the ball, and that is 3.36 meter, and this distance can only be obtained by making sure that every other component is in constant, which is what we have already said before: the height of the ball release, the strength that Nash put in throwing the ball, and the angle of the ball release. So by making all these variables constant, Nash can shoot at 3.36 meter and then can confirm that the ball will always land to inside the hoop.